Welcome to part 6. Before Jenkins pipelines were introduced, Jenkins automation was mainly built using freestyle projects. Freestyle project is the simplest type of Jenkins job. It allows us to configure the source code, build commands, testing, and deployment through Jenkins graphical interface. Initially, this worked very well because projects were small. Suppose a software team only needed 3 activities: compile the code, run the test, and deploy the application. 3 freestyle jobs were enough. However, as software projects become larger, organizations started creating many freestyle projects and linking them together. Eventually, managing these jobs become increasingly difficult. Today, we will understand why this happened and how Jenkins pipelines solved these problems. Let's first understand how software was automated before Jenkins pipeline. So let's see the traditional Jenkins freestyle projects. In the earlier versions of Jenkins, every stage of the software delivery process was created as a separate freestyle project. For example, job 1 would compile the code. After compilation finished successfully, it triggered job 2. Job 2 executed unit test. If testing passed, it triggered job 3. Job 3 created the application package. Finally, job 4 deployed the application. Notice something important. Each step is actually an independent Jenkins job. These jobs do not know anything about each other except that one triggers the next. This approach is called job chaining. So how were these jobs connected? To connect freestyle jobs, Jenkins provided the plugin. So one of the most popular plugins was Build Pipeline plugin. So this plugin allowed one job to automatically trigger another. For example, compile completes, then automatically trigger testing, then testing succeeds, then automatically trigger packaging, then packaging succeeds, then automatically trigger the deployment. So the plugin also displayed these jobs visually in Jenkins. So looking at the screen, the developer could immediately see which job succeeded and which failed. At first glance, this looks very organized, but underneath every box is still a separate configuration. Each one has its own setting, its own workspace, its own parameters, its own permissions, its own maintenance. So this worked well initially, but problems appeared as projects become larger. Now imagine a real enterprise application. Instead of 4 jobs, we now have compile, unit testing, job for static code analysis, security scanning, package creation and image creation, deploy to development, integration testing, then performance testing, deploy to staging, approval, and many more. So instead of 4 jobs, you now have 15 or 20. Each one is configured separately. Each one triggers another, so the diagram becomes larger and more confusing. Now imagine adding just one more stage in the middle. Where do you update it? Several jobs need modification. That's where the maintenance becomes painful. Let's understand the specific problems. Problem number 1 says configuration is scattered. So instead of one pipeline, the configuration is spread across many Jenkins jobs. To understand the flow, developers have to open multiple projects. Problem 2 is too many jobs. An enterprise may have hundreds of freestyle projects, so finding the correct one becomes very difficult. Problem 3 is maintenance becomes expensive. Suppose your Maven version changes. Now you must update every freestyle job individually. Problem 4 is plugin dependency. The build pipeline plugin itself becomes another component that must be installed, upgraded, and maintained. Problem 5 is version control is impossible. So freestyle jobs are configured through Jenkins GUI and configuration is stored inside Jenkins, so it is not naturally stored in Git. If Jenkins crashes, restoring configuration becomes very difficult. Job 6 is reusability is very limited. If another project needs the same workflow, developers often recreate many jobs manually. So the industry needs a better solution. Jenkins pipelines completely changed how automation is written. Instead of creating many independent jobs, we write the entire workflow inside one file that is called JenkinsFile. So this file contains every stage: the build, test, package, deployed, everything is written together in a code. Rather than clicking around the Jenkins interface, we simply write the code. This approach is known as pipeline as a code. Just as developer writes application code, they now write automation code. Let's compare both approaches. So in freestyle projects, automation lives inside Jenkins, but in pipelines, automation lives inside Git. This means every pipeline change is tracked. We know who changed it, when changed it, why changed it, and rollback is so simple. Notice how simple is this. Everything is written inside one Jenkins file. First, the build stage executes. After the successful completion, the test stage runs. Finally, the deploy stage starts. Every stage is clearly visible. No need to create separate freestyle projects. If tomorrow we want to insert another stage, for example, security scan, we simply add another stage. We do not create another Jenkins job. Now that we understand why Jenkins pipeline was introduced, the next question is, where do we write pipeline? The answer is inside a file called JenkinsFile. Think of a Jenkins file as a recipe. Instead of clicking buttons in the interface, we write instructions in text file. When Jenkins reads this file, it creates the instructions exactly in the order we have written them. So Jenkins files are written in Groovy based index. The declarative pipeline uses Groovy underneath, but you would not need to become a Groovy expert. You only need to understand the pipeline keyword and a small amount of Groovy index. So the first keyword is pipeline. This tells the Jenkins everything inside these braces belong to one pipeline. Just as a Java program starts with a class or a C program starts with a main function, Jenkins declarative pipeline begins with a pipeline block. The opening brace means the content of the pipeline starts here. The matching closing brace at the end marks where the pipeline finishes. Think of a folder on your computer. The folder is called the pipeline, and everything inside that folder belongs to that pipeline. So many beginners often confused by these curly braces. So curly braces simply create a block. Everything inside the brace belongs together. For example, stage and then their braces means everything inside belongs to this stage. Next is the keyword agent any. So this is one of the most important statements in Jenkins files. The word agent tells Jenkins which machine should execute this pipeline. The word any means run on any available Jenkins agent or node. Suppose your Jenkins installation have 5 build servers. Jenkins checks which one is free and automatically runs the pipeline there. So imagine Uber, you request a ride, you do not specify which rider should come. Uber sends any available rider. Similarly, agent any means use any available build machine. There are other options like agent any, run means run anywhere. Then we have agent none, means no agent is assigned globally. And we have another syntax like agent label, and we can give a label there. So this means or this implies that run only on a machine labeled, for example in this case Linux. The next keyword is stages. Notice it is a plural. Why? Because pipeline usually contains more than one stage. For example, build, test stage, package stage, deploy stage. So all these stages are grouped together inside the stages block. Think of this as a container that holds every stage of your software delivery process. Inside the stage block, we define one stage at a time. Here we have stage named build. Keyword stage means creates a named section, and the text inside the parenthesis is simply the display name. It is shown in Jenkins user interface. If I write stage testings and Jenkins display a stage called testing, we still need to tell Jenkins what work actually happened. So this is why every stage contains a steps block. Inside steps we have we place the actual commands that Jenkins execute. So think of cooking. So one stage is prepare vegetables. So steps would be wash the vegetables, peel the vegetables, and then cut the vegetables. So the stage is the heading and the steps are the actions. The word sh means execute a Linux shell command. Everything inside the ports is passed directly to the Linux terminal. For example, sh and then pwt. So this prints the current directory. If Jenkins runs on Windows, we usually use bat instead of sh because Windows uses batch commands rather than Unix shell. Now let's review the entire Jenkins file from top to bottom. So line number 1 start the pipeline definition. Line number 2 tell the Jenkins to run on any available agent. Line number 3 begin the section that contains all the stages. And then line number 4 create a stage named build. Line number 5 start the block containing executable actions. Line number 6 execute the shell command mvn The pipeline contains stages, stages contain stage, stage contains steps, and steps contains the commands. So this hierarchical structure is what makes the Jenkins files readable and very easy to extend. Now that we know a pipeline is written inside a Jenkins file, the next question is, how do we write it? Jenkins file can be written in two different syntaxes. One is the declarative pipeline and the second is the scripted pipeline. Although both used to automate CI/CD workflows, they are constructed differently and follow different programming styles. The scripted pipeline is an older approach. It provides greater flexibility, allows the developers to write complex logic using the Groovy. However, because it relies more heavily on Groovy programming, it can become difficult to read and maintain, especially for beginners. Declarative pipeline is a newer and more commonly used approach. It was introduced to make the pipeline development simpler, more structured, and easier to understand. So it provides a well-defined syntax with predefined sections such as pipeline, agents, stages, stage, and steps. So this structure makes the code easier to read, easier to write, and easier for teams to maintain. Throughout this course, we use declarative pipeline syntax because it is the recommended approach for most CI/CD projects. Later, after we become comfortable with declarative pipeline, we will briefly discuss the scripted pipeline and understand where they are useful. So from this point onward, whenever we create a Jenkins file, we will create a declarative pipeline syntax. Now let's see how actually we create a declarative pipeline. So the process is quite simple. First, open any editor or integrated development environment. Next, create a new file. Traditionally, this file is named as JenkinsFile. Some learning environments may use .groovy extension because pipeline is based on Groovy syntax. But in real Jenkins projects, the standard file name is simple Jenkins files without any extension. Once the file is created, write the declarative pipeline code inside it. Initially, we will start with a very simple pipeline containing just one stage. As we progress through the code, we will gradually add build, testing, packaging, Docker, and deployment stages. After writing the pipeline, customize the stages and commands according to your project's requirements. For example, one project may use Maven, another may use Gradle, and another may use NPM. So simply deployment steps will differ depending on the target environment. After making the necessary changes, save the Jenkins file. Finally, configure your Jenkins job to use this Jenkins file. So when the job starts, Jenkins reads the file, interprets the pipeline instructions, and executes each stage in sequence. Jenkins Pipelines provides several powerful features that make CI/CD automation more reliable, maintainable, and scalable. One of the biggest advantages is that the pipeline is written as a code. Since the Jenkins files is just another file in the project, it can be stored in a version control system such as Git. This means every change to the pipeline is tracked, previous versions can be restored, and team members can collaborate using the same version control practices they already use for application code. Another important feature is user interaction. During pipeline execution, Jenkins can pause and wait for user input before continuing. For example, after deploying to a staging environment, the pipeline can ask for approval before deploying to production. Pipelines can also be resumed or restarted from certain checkpoints, saving the time by avoiding the need to rerun the entire workflow. Jenkins pipelines can support parallel execution. Instead of running every task one after another, multiple independent tasks can execute simultaneously. For example, the application can be tested on a different operating system or different Java versions at the same time. Running these tasks in parallel significantly reduces the overall execution time. So these capabilities like pipeline as a code, version control integration, interactive execution, and parallel processing are some key reasons why Jenkins pipeline have become the preferred approach for implementing the modern CI/CD workflows. Now that we have learned the basic syntax of Jenkins file, let's create our first Jenkins pipeline inside Jenkins. I'll switch to the Jenkins dashboard. The first step is to create the new item. Here I'll provide the name of the job. Instead of selecting Freestyle project, notice that now I selected pipeline because we are creating a Jenkins pipeline. Next, click OK. Jenkins opens the job configuration page. If we scroll down, we'll see several configuration sections. The most important one is the pipeline section. This is where we tell the Jenkins what pipeline it should execute. Since this is our first example, rather than writing the code manually, Jenkins provides convenient option called sample pipeline. I'll select the hello world from that sample pipelines. Immediately, Jenkins generate a complete declarative pipeline for us. Before we execute it, let's understand what we are looking at. Notice that this Jenkins file is divided into different blocks. The keywords such as pipeline, agent, stages, stage, and steps are called sections or structure blocks of a declarative pipeline, and they define the overall structure of the pipeline. Inside these sections, we use instructions that are called directives or steps to tell Jenkins what actions to perform. For example, echo hello world step simply prints a message to the Jenkins console output. So the structure tells Jenkins where things belong, while the step tells Jenkins what to do. Now let's save the pipeline. Once the configuration is saved, we are taken back to the project page. To execute the pipeline, simply click build now. Jenkins immediately start executing the pipeline. After a few moments, the build completes successfully. Now notice something new on the project page. We can see a section called Stage View. Stage View provides a graphical representation of a pipeline execution. Each box represents one stage defined in a Jenkins file. If a particular stage fails, for example the testing stage, we immediately know where the problem occurred without examining the entire pipeline. So this makes troubleshooting very faster compared to the chained freestyle jobs. Now let's see one of the biggest advantage of Jenkins file. So suppose we want to add another stage called testing. So in a freestyle project approach, we would have to create a completely new Jenkins job and then configure it and then connect it to the previous job using that build pipeline plugin and then update the entire workflow. As the number of jobs increase, this becomes obviously difficult to manage. So with Jenkins pipeline, adding another stage is much simpler. It simply means copying the existing stage. So paste it below, rename the stage from hello to testing, modify the command, for example echo running test, save the Jenkins file, that's it. No new Jenkins job, no additional plugin, no complicated configuration, and we have simply extended our pipeline by adding another stage. Pipeline as a code has several advantages. So this demonstrates one of the greatest advantages of Jenkins pipeline, that is pipeline as a code. Instead of creating and linking multiple Jenkins jobs through a graphical interface, the entire workflow is described in a single text file. If tomorrow we need to add a package, Docker build, security scan, or a deployment stage, we simply add another stage block to the Jenkins file. So this file can also be stored in Git. Every pipeline change is version controlled. We know who modified it, when it was modified, and we can easily revert to the previous versions if required. So this approach makes the pipelines easier to understand, easier to maintain, and much more scalable than traditional freestyle jobs connected using the build pipeline plugin. So in the next lecture, we will be discussing scripted pipeline and declarative in a more detailed view, reviewing the input directives and environmental variables.